This is the second video of my UniFi MC-Lag series. In the first video, I briefly talked about how it's configured and showed you several demos. In this video, we are going to directly jump into the backend and packet capturing. In my lab environment, I have this EFG with shadow mode plus MC-Lag setup. So the two ECS-Aggregation switches are linked using the port 53 and port 54. In the right side, you can see the stacked two ECS-Aggregation switches. And then in the right side, you can see two other switches. They are also using link aggregation connected to these two ECS-Aggregation switches. And if I click on the stack, go to port manager, then go to the MC-Lag tab, there's only one MC-Lag group. By the way, I cannot create a second one because I only have two switches which support MC-Lag. Click on the MC-Lag group. So you can see the 53 and 54. They are crucial for this MC-Lag setup. They are for the multi-chassis links. So this is what we can see from the front end. In fact, to make the MC-Lag works, there are a lot of internal setups which are hidden from the front end. You don't see them at all. This video is for deep dive. Let's go to the backend to find the hidden information out. So in the lower part, two terminals, let me SSH to the two ECS aggregation switches. Let's run a SONiC OS command to show the interface status. You can see, except for the ports, which you can see from the front panel of the switch, you can also see several port channels. In SONiC OS, port channel means lag. You see multiple port channels here. Later we will see why we have them. But for now, let's see the Ethernet 53 and 52. These two interfaces, they correspond to the port 53 and the port 54 are used to establish the multi-chassis link. They are members of this particular port channel 129. In fact, the multi-chassis link 5354 is also a port channel, just like the ones you see here. Ubiquiti labels them as target device membership, but technically, multi-chassis link is also a port channel. It's just there will be additional network traffic going on in these two links. Later we will see it's for ICCP, specifically related to MC-Lag. If you used other vendors' switch, you may know they may support a command for show MC-Lag brief. However, it's not supported in this UniFi switch. If we try to show help for show command, you can see MC-Lag is not listed in the available options. So we don't have standard way in SONiC in this UniFi switch to show the MC-Lag configuration. But let's continue digging. You may know in SONiC OS, show is to display the configuration, right? You can also use config command to change the configuration. So if you see the available options for config, so you do see MC-Lag. That's perfect. It may give us some clue about what's going on, right? So let's continue. Config MC-Lag question. So we have these options. Let me explain them one by one. The add delete is for manipulating the so-called MC-Lag domain. In backend, it's called MC-Lag domain. In frontend, it's called MC-Lag group. They are the same thing. Then the keep alive interval is something going on between these two switches on these red links. The two switches will send out a heartbeat packet just to keep alive. Then there will be log, and here is configuring member. This switch is a member, this switch is another member. Here you can configure timeout, and the very last option is very unique and is very important for this video, but the name is very confusing. It's called unique IP. So later we will explain what's unique IP. In fact, it's part of the special VLAN used by Ubiquiti. So now just by using the config command help, we can already see a lot of hidden information about MCLAG. In the front end, we already have a MCLAG group maintained. How we can see the internal configuration, right? If you want, you can use the SONiC OS DB CLI to get the database entries. So let me show you. So let me run this command first, SONiC DB CLI. What I'm saying is, let me query the config database, list all the keys which contain MCLAG. Okay, you can see the keys separated by this side. We don't see values here. So to see the value, for example, this particular one, remember I mentioned MCLAG domain is just internal name for what we see on the UI, which is MCLAG group, right? So let me see what's behind this database key. So the way to see it is, what I'm saying is I still run this SONiC DB CLI command. I still want to query the config DB, but here the command is different. I don't want to list the keys. Instead, I want to list the values for this key. Where do I get this key? From previous output here. So let me run it. It gives us very important information. The peer link is internal name for the multi-chassis link we see on the UI. So here we can see the port channel 129, which I labeled here in the diagram, is for the peer link. And here you can see the source IP, which is the IP address for this particular top switch. It has this strange IP address. You will see this address is part of VLAN 4050. Then here it specifies the peer IP, which means the other end. The other switch, in my case, is this ECS-Aggregation bottom switch. And it has another very strange IP address. Later you will see. So just by querying the SONiC DB, we can get a lot of hidden information. If you want, you can continue to list the values behind other keys. Let me show you another way to get the information. In my opinion, maybe that's better than directly querying the database. So the command is called mclag-d control. So we can dump the different configuration. For example, I can dump the current state. It lists a lot of information, whether it's keep live is okay or not, whether it's synchronized, what's the domain ID, what's the IP address, what's the peer link interface, a lot of useful information. Then let me run the command in this way. I want to dump the port list, which is the local port list. I'm only interested in the domain ID 1, which is the one we see on the UI, this particular MCLAG group. So let me run it. It lists multiple local ports which are related to this MCLAG. So far, I just want to give you some idea about how to see the hidden information in Backend. Now, let's move on. Let's look into the information we get from Backend to understand how MCLAG works. MCLAG is to enhance network availability and provide redundancy. It achieves that by creating a logical link aggregation group across two independent switches, and they are called MCLAG peers. This allows a client device, for example the Mac machine here, to connect to both peers and treat them as a single logical entity, forming a lag that spans two chassis. If one MCLAG peer fails, the other one can continue to provide network connectivity, minimizing downtime and improving overall network resilience. These two MCLAG peers utilize ICCP to exchange control information and coordinate their actions. ICCP stands for Inter-Chassis Communication Protocol. Just like this Ubiquiti diagram shows, MCLAG includes two most important underlying components: the regular lag, either upstream or downstream, and the multi-chassis link. Unlike the regular link aggregation, which uses LACP, the Link Aggregation Control Protocol, which is a IEEE standard, there's a common implementation, right? The multi-chassis link it's missing some industry standard. Different vendors have different implementations. So let's see how Ubiquiti implements this part, the multi-chassis link. You may know Ubiquiti's ECS-Aggregation switch uses SONiC OS, and SONiC OS runs in Dockers. So in the left side SSH, let me run Docker PS. You can see this one, ICCPD, is daemon for ICCP. To see what's running inside the Docker, we can run Docker exec it ICCPD bash. So basically what I'm saying is, let me log on to this Docker and using bash as the shell. Okay, I'm in. See, the prompt is changed. I'm in the Docker. Now I can see what's the running processes. So let me run ps grep ICCP. You can see ICCPD is running. And if you want to see what port number is listening, we can run netstat. It's listening on port 8888. You can see from this machine, it is communicating with another machine. Interestingly, the port number is also 8888. If in the right side, I do the same thing, I run Docker, ICCPD is running, then log on to ICCPD, then run ps, the same ICCPD is running, then run netstat. You can see the exact same situation. So in this switch, ICCPD is listening on 888. At the same time, this machine from this port number is communicating with the other machine, which is the left side switch. So here we can already see two very strange IP addresses. From the left side, we can tell this 10 dot something ends with .1 belongs to the first ECS aggregation switch, and this particular one ends with .2 belongs to this second ECS aggregation switch. So what's going on? What are these strange IP addresses? So in the left side switch, let me run mclag-d control. Let me dump the unique IP information. And here I only want to see the mclag group 1 information. The multi-chassis link, or ICCP, relies on VLAN, more specifically VLAN 4050. So remember earlier we talked about there's no industry standard when it comes to ICCP and peer link implementation. SONiC OS and Ubiquiti, they are using a special VLAN for the peer link communication. Then let me continue. Run show VLAN brief. This is a SONiC command. Oh, I'm still in the ICCPD Docker. Let me exit it. Now I'm back to the switch. Then run the SONiC command, show VLAN brief. It lists the two networks which I configured in UniFi Network Controller, default network and the VLAN 10. You can confirm in UniFi Network Controller, VLAN 1 and the VLAN 10. However, in the end, you can see this VLAN 4050, and it is in this subnet. This port channel 129 is tagged with this VLAN, and more interestingly, this VLAN is not listed in UniFi Network Controller. It's hidden. It exists in backend, but not shown in the front end. Then let's find out the details of this VLAN 4050. Here it mentioned the port channel 129, right? Then let me run SONiC command, show interfaces, port channel. You can see for port channel 129, it includes two ports, Ethernet 52 and Ethernet 53. These two are the internal name for port 53 and 54. Let me go back to the mclag configuration. For the multi-chassis link, we use port 53 and 54, right? They exactly match these two ports. Port channel 129 is tagged with VLAN 4050. It is for the multi-chassis link, and the system uses it to transfer ICCP related messages. If I run the Linux OS level command, show the IP address, you can see this VLAN 4050 interface, and for this left side switch, it has this .1 IP address. And for the right side switch, if I run the same command, you can see it has the .2 IP address. Both addresses belong to VLAN 4050. And then let me run another MCLAG-D control command to dump the port list for local. Local means this particular switch which I'm running the command in. I only want to show the MCLAG group 1. Let me run it. It shows a long list of interfaces. And this IF index is from OS level, the interface index. This might be difficult to relate to the port number, but you see here it does mention port number. So you can see I have many ports, right? Why they are here? Why they are listed as the MCLAG related ports? So if I go to the ports, for example, what's Ethernet 40 is for the port 41. It's used to establish the link aggregation to downstream switch. And then what's Ethernet 35? Yeah, it's here. I configure it and I use it to demo in my previous video for one of the Apple computers. The Mac machine use link aggregation to connect to the two switches. And then for another example, Ethernet 0, which is for the port 1, is used to connect to upstream device, which is EFG. Basically, the system lists out all the ports which are related to the MCLAG configuration. Let me show back the MCLAG. See here. So basically, what you see in the SSH for the port list are exactly what you see here for multi-chassis link and for the target device membership. They are all part of the MCLAG for different reasons, either for multi-chassis link or for upstream device or for downstream device. And you can run another flavor of this command. Instead of saying local, you can say peer. What does it mean? You can see the differences for the peer command. It only lists the related port channels. To put another way, whatever you see on the UI, you will see the corresponding port channels in this command output. Before moving on to the last part, let me show you one more thing. Let me log on to the ICCPD Docker again, then go to etc ICCPD. You can see there is a configuration file. But this file is ridiculously simple. It simply records the system MAC address. In this slide, I already note down the MAC address here. Then let me exit the Docker, show the IP link command result. And for Ethernet 52 and 53, you can see they are showing the MAC address here. They match exactly to the one we saw in the ICCPD Docker. By the way, you may notice all the way from Ethernet 0 to Ethernet 53, they have the exact same MAC address. Because they are all the parts in the front panel of the switch, they are part of the switch fabric. Their real address is not exposed to the Linux. They are managed by the switch fabric. So that's why from the OS level, they have the exact same MAC address, and it's the same one listed in the ICCPD as the system MAC address. Okay, and then for the other ECS-Aggregation switch, if I run IP link, I will get another MAC address. I list the same in the diagram. So now let's proceed to the very last part of the video, Wireshark capturing. I'm going to capture the packets for these two red links, which are for the multi-chassis link. And then one of the two downstream link aggregations to the switches. We know they behave differently because the red links, they are not only using link aggregation, but also ICCP, right? So let's understand the details using Wireshark. In the right side for UniFi network controller, if I go to port manager, you can see I already connected two Mac machines, which are showing in the lower part of the screen. Port 20 in the first ECS aggregation switch and port 18 in the second switch. Because first I want to capture these four dark blue ports, right? Because they are for the multi-chassis links. To capture them, apparently, I want to first try the regular port mirroring. Let's say for port 20, I go to advanced setting, and for operation, I choose mirroring, and for mirroring part, I select 53, which is this part, right? No problem, apply changes. But if I want to move on, let's say for the second Mac machine, in the second switch, go to advanced setting, I don't see the options to set it to mirroring anymore. So in the past, you may know if we just talk about one single UniFi switch, on the UI, Ubiquiti doesn't allow you to set two parts to the mirroring mode. So to achieve that, you have to go to the backend to run CLI. However, for this case, we are talking about two physical switches. Once we enable port mirroring in the first switch, I cannot set anything in the second switch anymore. That's strange. My thought is it's a bug from Ubiquiti. Someone may ask, is that because when you set the MC lag, you choose stacking so that the system treats the two physical switches as one single virtual switch? Okay, let's do some testing. Let's disable the stacking. Then let me go back to parts. Here what you see is the top switch. Let me go to the bottom switch, and this is the part 18. I want to make change. See, if I go to menu, the same situation. I don't see the operation drop down. Okay, so basically the stacking or not is not the reason for my issue at all. So let me change it back. And then, as I mentioned in the past, to resolve this, it's very easy. I can easily go to the backend to run CLI, right? But you may know for this ECS-Aggregation switch, it doesn't run the traditional Ubiquiti backend CLI. It runs SONiC. In SONiC OS, to configure span or port mirroring is different than traditional Ubiquiti CLI, but it is supported. For example, in SSH, you can run SONiC config command using mirror session, add a session name. For example, let me say span2. Then you specify the Ethernet port. For example, Ethernet 19. This is how you specify port mirroring from backend using SONiC CLI. However, we have a better way, easier way in my case. Because anyway, in backend, these two switches run Linux. As long as it's Linux, we can use the remote packet capturing supported by Wireshark. Let me show you. Before that, let me change back this port 20 to the regular switching operation instead of port mirroring. Then in Wireshark, let me show you how to do that. The left side Mac machine is connected to the port 20 of the first ECS-Aggregation switch. You can see in the options for Wireshark, there's one called SSH remote capture. So let me click on the setting first. I set the first ECS-Aggregation switch IP address here, and of course port 22. For authentication, I specify the regular SSH credentials. For capture, because I want to capture the port 53 internal name, it's Ethernet 52, and I want to use TCP dump, which is installed by default in the switch. Then I accept the default remote capture filter. It simply filters out the SSH related packets. Let me start capturing. By the way, I didn't show you the additional step which is needed to change the internal SSH daemons configuration to enable username password logon. Okay, let it run, and in the right side, it's connected to the port 18 of the second ECS-Aggregation switch. So I click on the setting. For IP address, I provide the second switch IP address. Authentication, the same credentials. Capture, because I want to capture the port 54, internal name, Ethernet 53. Then start capturing. If you check the first and the second Wireshark sessions, you can see they are not exactly the same. So for the first, it includes LLDP, which is for the hierarchy, STP, and it has some LACP packets, which are related to link aggregation. But if you check the right side one, it only includes mainly two types of packets. Most of them are TCP packets. It has some LACP packets. To understand the difference between the two Wireshark sessions, let me first set the filter to LACP in both sessions. So you can see they have back and forth LACP communications between the two switches. You may know LACP is not based on UDP or TCP. It is a type of slow protocol. And you can see half of the packets were from the first ECS aggregation switch because the MAC address match what I noted down in the diagram, and the other half is from the right side ECS aggregation switch because the MAC address match this one. If you check a random packet, for example this one, you can see it is a slow protocol. Subtype is LACP, and when it comes to LACP details, you can see it has actor and partner, two different roles. So for this particular example packet, the actor is the left side switch, the partner right side switch. For the four dark blue for the two switches, I set them to use link aggregation. That's a prerequisite for them to become multi-chassis links. So if you just check the LACP packets, they just work in the same way as regular link aggregation. Then if you check the right side, you see similar thing. Half of the packets were from the left switch, half of them were from the right one. And why we see LACP in both parts? Because it's link aggregation for either of the two links. The system need to establish the link aggregation to exchange LACP packets. So far so good. We see the LACP thing. But remember the special thing for these two links is they are multi-chassis links. Let me remove the filter. Now you see the difference. We only see the TCP packets in the right side. If I click a random one, let's go to the details. The first thing you may notice is the VLAN tag. See what's the VLAN ID? 4050. This is the crucial special VLAN we spent a lot of time previously. It's configured in SONiC OS. This VLAN is crucial for the two switches to exchange ICCP packets. Okay, and this particular example packet is in VLAN 4050, right? Then if you check the IP information, you can find the source and the destination. They are exactly the unique IP of the two switches. And because this packet exchanged in this VLAN 4050 uses TCP, so that's why in the last section you see the TCP information, right? This packet is a acknowledged packet. If I choose some other random TCP packets, you can see some of them do have data. Depending on the usage of the packet, you will see different lengths of data. As we mentioned previously, the ICCP doesn't really have industry standards. Each vendor has their own implementation. It's proprietary, so I really don't have any information to decode what's inside in the data part, but we can guess the two switches may be doing MAC address synchronization. If one switch is unreachable, the other switch will react to take responsibility. In ICCP, the two switches may also be doing peer discovery. The system are doing something using ICCP to maintain the MC lag. Yeah, you see the packets in real world for the multi-chassis links, right? So let me stop capturing. Next, let's look at some downstream switch link aggregation. So in the UniFi network controller, if I go to MC lag, for this MC lag group, you can see for, let's say, port 41 is one of the target device membership, right? If you go to ports, you can see port 41 of both switches. They are connected to the USW Enterprise XG24. In the other end, in the Enterprise XG switch side, I enabled link aggregation in these two ports, the port 25 and the port 26. That's how this switch is connected to this two ECS aggregation switch. And these links are regular link aggregation links. Let's do some packet capturing as well. Let's see how it behaves differently than the one we just checked, the one for multi-chassis link. In the same way, I'm going to use these two Wiresharks. I just need to slightly change the remote capturing setting. So for the left Wireshark, it's the same switch, the same authentication, but for capturing, I need to change it to Ethernet 40, which means port 41. So this is for the first ECS aggregation switch. Start it. Then for the right side Wireshark, change it in the same way. Ethernet 40. Start. Okay, so you can see the difference between these two parts, right? The common thing is they both have LLDP and LACP, but the left side session also has STP packets. If we check the LACP in both ends, you can see the regular link aggregation information. One end is actor, the other end is partner. But if you compare this with previous one, I don't have those TCP packets, VLAN 4050 packets, because these links are not multi-chassis links. They are not for the peer connection. They are regular downstream link aggregation. Okay, this ends the video. Thanks for watching.